unlucky stars fall into pits of gravity in the sky and turn into hurricanes of hot gas. To gauge the cosmic storms, you need telescopes in space. And Europe's X-ray multi-mirror satellite, XMM, is the latest space observatory. A force of unseen matter rules the galaxies, but hot gas, radiating X-rays, reveals its concentrations. By catching the X-rays, XMM will explore the hidden architecture of the cosmos. And at the dawn of time, did black holes rule the universe? If so, XMM may rediscover that lost world as the most powerful X-ray satellite ever built. XMM is a glutton, with a prodigious appetite for cosmic X-rays. It will analyze bright sources very quickly and detect many extended faint sources for the first time. To make XMM as greedy as possible, ESA and Europe's industries pushed telescope making beyond the limits of known technology. Wafer-thin mirrors with golden faces nest together like Russian dolls in 3 modules with 58 mirrors apiece. All of the mirrors had to be shaped and put together with immense precision, so that X-rays go to the same focus at the far end of the satellite. And the assembled module is strong enough to survive the conditions at launch and in space. 3 modules to gobble up the X-rays from the sky, with altogether 174 mirrors and 120 square meters of high-precision optics. If you think the stars look serene, XMM may change your mind. Mother Nature is far from gentle in the X-ray hotspots. But it's a creative violence. Chemical elements in the human body came from stars that blew up long ago. XMM will trace our stellar ancestry by inspecting the remnants of recent explosions. They also throw out powerful atomic particles that rain non-stop upon the Earth. XMM will pin down the precise sources of these cosmic rays. As a great X-ray observatory, XMM will examine the vampire stars that suck gas from their neighbors, the cores of galaxies where stars are shredded by black holes, the congested clusters of galaxies where traffic accidents are commonplace, the unimaginable super explosions called gamma-ray bursts. Space scientists want to know how such a violent universe nevertheless created pleasant oases like the Earth, where fragile life can survive. They said it couldn't be done. No one could make X-ray mirrors so large and so thin, but so brilliantly perfect. It took a lot of trial and error, but XMM finally got the mirrors it needed. First, they had to make the molds. 58 cylinders, each one slightly smaller than the last, each one shaped to an accuracy of 1/1000th of a millimeter. And then the polishing began, to make them 1,000 times smoother. The mirrors themselves were made in Italy. In a vacuum, a super-thin film of gold was deposited on the molds. In order to get this golden mirror from the outside of the mold to the inner surface of a shell, a millimeter-thick coating of nickel went over the gold. Once the wafer-thin shells had been gently eased off the molds, the gold mirror had become the inside of the cylinder. The technicians making these large but very flimsy shells had to be incredibly careful with them. Less than a millimeter thick, the mirrors could easily get bent out of shape just by their own weight. The mirrors are nested like Russian dolls barely 3 millimeters apart. And again, incredible accuracy is the order of the day. This time, it can only vary by 1/4 the width of a human hair. Having built 3 mirror modules, ESA went on to build 2 more, so that once each module had been carefully tested to make sure it lived up to all those precise specifications, the 3 best ones could be sent into space. Our newest electronic eyes in the sky are on board XMM, the European Space Agency's X-ray multi-mirror satellite. XMM's main eye is the European Photon Imaging Camera, or EPIC. Incoming X-ray photons hit small semiconductor chips in the 3 EPIC cameras, one of which uses the largest CCDs ever made for X-ray detection and specially developed for XMM. They convert the X-rays into electronic signals that can be recorded. XMM's other electronic eyes are the reflection grating spectrometers, a latticework of gold-covered plates with extremely minute grooves in them. Placed at the end of 2 of the mirror modules, they spread out the X-rays the way a prism does with visible light. XMM is the first space observatory to use the technique, and these particular eyes will see clearly into the lower end of the energy spectrum. To give XMM's telescopes the longest possible viewing times, the satellite's orbit is egg-shaped. It loops out to a distance of over 120,000 kilometers, then swings back through the radiation belts, where particles form a kind of electronic fog that could interfere with the spacecraft's instruments. But XMM will have clear skies for 40 hours in each 48-hour orbit, giving scientists plenty of time to peer into the heart of the universe. Because of its 10-meter total length, the spacecraft was conceived in 2 halves: a service and propulsion module and a focal plane assembly, carrying the science instruments, each with a section of the long telescope tube. After separate environmental testing of the 2 spacecraft halves at ESA's ESTEC Technical Center in Noordwijk, Holland, and installation of the mirror modules on the service platform, the day finally came when the 2 parts could be mated, giving an idea of the size of the spacecraft that is flying today. After deployment tests of its 16-meter span solar array and an acoustic chamber test, XMM's last long journey constituted yet another logistical exercise. What happens when crowded galaxies collide? How fast does the universe expand? How do clusters stay together in spite of the expansion? And the most awkward question of all, what is that invisible dark matter? The cosmic X-ray background is a mystery too. It fills the gaps between the X-ray hotspots where known stars and galaxies are behaving violently. When XMM's predecessor, the German-built ROSAT satellite, stared for 300 hours at a patch of the sky with no obvious sources in it, faint hotspots came into view. Probably distant galaxies busy making stars. The super-sensitive telescopes of XMM will see the far-off galaxies without even trying. They'll show up in the background whenever a nearer galaxy is being examined. And when XMM itself spends a few days staring at one small blank patch of the sky, even more faint sources will come into view. But astronomers doubt if there are enough faint galaxies to explain all of the cosmic X-ray background. Does the rest come from an era when galaxies scarcely existed? Perhaps when black holes ruled the universe. Until XMM gives its verdict on the big picture, who knows?